Hello everyone, welcome back to the most important topic, pre-formulation studies of B.Pharmacy 5th semester syllabus. So, in the last lecture, we completed with the different types of crystalline compounds, that is the simple crystalline compound and the special crystalline compound. So here we can see that the special crystalline compound was further divided into polymorphs and molecular adduct. So, in the last discussion, we also said about polymorphs and the term polymorphism was clearly discussed. So, here we can see that when a substance which exists in more than one crystalline form, the different forms are designated as polymorphs, and this phenomenon is known as polymorphism. And polymorphs are also further divided into enantiotropic and monotropic compounds. And polymorphs are the single molecule as they contain single type atom. Its internal structure changes than original form. And the most important thing is that polymorphs have similar chemical properties, but they have different physical properties like melting point, solubility, and so on. So now come with the different types of polymorphs. So polymorphs are basically of two types, the monotropic compounds and the enantiotropic compounds. So the monotropic compound is like only one form is stable at all temperature and pressure, but the remaining forms are metastable in nature. But in case of enantiotropic compounds, only one polymorphic state is stable at certain temperature range, while another polymorphic forms is or are stable at a different temperature range. Means what we can say that more in case of monotropic compounds, only one form is stable at all temperature and pressure, but the remaining forms are metastable in nature. But in anisotropic compounds, every form are stable at different temperature and pressure. So now let's discuss detailed difference between the enantiotropic compounds and the monotropic compounds. So in case of enantiotropic compounds, we can say that it can be reversibly changed into one form to another form when temperature and pressure is changed. But in case of monotropic compounds, this type shows irreversible phase transition, means higher melting point usually exhibit by the thermodynamically stable form. Next one is like transition occurs by endothermic process in case of enantiotropic compounds, but in case of monotropic compounds, the transition process is exothermic in nature. And in anisotropic compounds, reversible phase transition is seen. In monotropic compounds, irreversible phase transition is seen. And the anisotropic compounds, the lower melting point means the lower melting form is thermodynamically stable below the transition temperature, and the higher melting form is stable above the transition temperature, which we have already discussed earlier, like that every form are stable. So in that scenario we can say that the lower melting form is basically stable below the transition temperature, and the higher melting form is stable above the transition temperature. And in monotropic compounds, the higher melting form is always thermodynamically stable form, because here only one form is stable at all temperature and pressure. Now next one is the method for analyzing polymorphs. There are certain methods for the analysis of the polymorphs. So the methods are as follows: microscopy method, optical crystallography method, fusion method, differential scanning colorimetry, thermogravimetric analysis, X-ray diffraction method, infrared method, scanning electron microscopy method, and dissolution and solubility analysis method. Now, next come with like we have already seen that the special crystalline compounds is divided into polymorphs and molecular adducts. So the next topic of discussion is the molecular adducts. So what are the molecular adducts? In molecular adducts, the entrapment of solvent molecules occurs in the crystal lattice, And how it forms, basically during the process of crystallization, some compounds have a tendency to trap in between the solvent molecules. So basically it contains the solvent molecules inside them, and so they get fixed there and they forms the molecular atoms. Next, the topic of discussion is that molecular adducts are also further divided into stoichiometric and non-stoichiometric compounds. So now let's come to discuss that what is stoichiometric compounds. In these compounds, the ratio is fixed, means there we can see a complete ratio like 2 is to 1, 3 is to 2, 4 is to 1, and so on. And this is the ratio between the crystal and the solvent. And the stoichiometric compounds are also known as the pseudo-polymorph. And why it is so called so? As it can exist in different forms as polymorphs. Means we already seen that polymorphs are the compounds which exist in different forms, and so the stoichiometric compounds are also like that. And stoichiometric compounds are studied by hot stage microscopy methods, and it contains two types of solvents like the organic solvents and the hydrates. In this organic solvent, in these solvents, we can see that organic solvent is incorporated other than water, and in case of hydrates we can see that the solvent which is entrapped is water. Okay, and next come with the non-stoichiometric compounds. In these compounds, the ratio is in fraction like 1.5 is to 2 is 2.2, 3.5 is to 4.2, and so on. They are also known as inclusion compounds. Molecular crystals during the crystallization enter the solvent within the crystal lattice, and it contains the layer compound, cage compounds or clathrates, and channel compounds. So what is layer compound? In these compounds, solvent molecules are present in between the layers. And in what is cage compounds or clathrates? Most importantly, cage compounds are also known as clathrates, and this is one of the major important question which comes in every examination. So what is clathrates? In these compounds, the solvent molecules are present within the cavity of the crystal. And next is the channel compounds. In these compounds, the solvent molecules are present in the continuous channels. And here is a note, we can say that the anhydrous form of a drug, means the organic solvents or the anhydrates, have the greater aqueous solubility than that of the hydrates. Why it is so? Because hydrates in hydrates molecules, the water molecules are already captured in between them, so its solubility is low, because when we want to make them soluble in water, then it is not possible due to the presence of the water molecules in the hydrates. But in anhydrous form, there is no water molecules present, so that's why they can be easily get soluble in aqueous solution. Next point is anhydrous form has higher melting point and more aqueous solubility than hydrates. So as because it has anhydrous form has higher solubility, so its melting point is also higher and the aqueous solubility is also higher than that of the hydrates. There are some points which we have to get remembered, because these points are very important and it's always a major portion of the question answer. So the zinc insulin present in two forms. Here are some examples are given. So the first example is the zinc insulin, which is present in two form, amorphous or crystalline form. And the what is the amorphous form? Amorphous form is also known as the semi-lente, and it is rapidly get absorbed by intramuscular or subcutaneous route, but it has very short duration of action. and in case of crystalline or ultra-lentiform, it's slowly absorbed, hence provide long duration of action. So here we can see that both of the form has some advantages and also some disadvantages. So amorphous form is readily absorbed, but still it has short duration of action, and the crystalline form is slowly absorbed, but still it has long duration of action. So we formed a combined formulation like a lenti-insulin. And what is lenti-insulin? It contains 70% of alpha-lenti, means the properties of the crystalline form, and 30% of the semi-lenti, means the properties of the amorphous form. So here we can get both the advantages. As we need both, we need a rapid absorption and also we need long duration of action. So the lenti-insulin shows both of them. Next example is crystalline form of novobiocin is inactive, while amorphous form shows 10 times more bioavailability than crystalline form. And here we can see that the amorphous form have the highest solubility, and so they also shows the highest bioavailability. Next example, polymorphs have same chemical properties because it generate only one form single compound, but differ in physical properties like solubility, melting points, density, hardness, crystal shape, optical and electrical properties, vapor pressure, dissolution profile, and solubility. It is an important point. It's not an example. And geometric isomers and tautomer are not considered as polymorphs. About 40% of all organic compounds exhibit polymorphism. And the examples are like barbital, methylparabens, and sulfapyridine are existing in 6 polymorphs, while cortisol acetate is present as 8 polymorphic forms. Various polymorphs can be prepared by crystallizing drug in different solvents under diverse conditions. And the stable polymorphs represent the lower Gibbs free energy, highest melting point, and least solubility. The remaining polymorphs are also known as the metastable form. Due to high thermodynamic energy, the metastable form converts into stable form, resulting in low solubility. For example, cortisone 2 is more stable as compared to that of the cortisone 5. So here we can say that here is I can say a trick that the form which is lower form are seen to be more stable than that of the higher forms. So we can get memorized by this. And next example is chloramphenicol palmitate have 3 forms, and among them the form B have best bioavailability. So from B we can say that the best bioavailability. It is the trick to remember. Form B shows best bioavailability while A form is inactive, and inactive means it is more stable in nature. Next example is riboflavin 3 form is 20 times more water soluble than form 1. Next is what? Usually polymorphs number 1 has higher melting point and lowest energy than that of the other polymorphs. So these are the important points. You can go through this, and these are the most important points from which questions come in every examination. And now in the slide here we can say that we are now discussing some MCQs which are very important. So the hot stage microscopy is an important tool for the study of the pseudo-polymorphism. Next, which method is not used to detect polymorphs? That is, HPLC method is not used to detect the polymorphs. Number 3, polymorphs exhibit different properties except chemical structures, because polymorphs have the same chemical structures but they only differ in the physical properties. Number 4, substance exists in more than one crystalline form are known as polymorphism. Number 5, the polymorphic form 3 of riboflavin is how many times soluble than form 1? We have already discussed that it is 20 times more soluble than that of the form 1. Number 6, which insulin preparations of bovine origin is short acting? So we see that the insulin zinc suspension, the amorphous form or the semi-lentiform of bovine origin is short-acting form. Number 7, freeze liquid form is the another name of amorphous form. Why? Because amorphous compounds are formed by crystallization or freeze drying method. Number 8, which compound has highest solubility? The amorphous compound are less stable but still they have highest solubility. Number 9, extract powder diffraction method is used for the study of the crystalline compounds. And number 10, order of solubility of different forms of drug is amorphous form is much more stable than that of the metastable form, and metastable form is much more stable than that of the stable form. And here is the trick, like amorphous form is uh, less stable, then metastable form are slightly stable than that of the amorphous form, but still it is not stable form, and the stable form is the highly stable form. So the much more stable form is uh, shows lower solubility than that of the metastable form, and metastable form also shows lower solubility than that of the amorphous form. So the next topic of bulk characterization is hygroscopicity. So what is hygroscopicity? It is the ability of a substance to attract and absorb moisture from its surrounding environment, leading to the increase in their weight and physicochemical properties. These hygroscopic substances have a strong affinity for water molecules and can readily absorb moisture from humid air or aqueous environments. Basically, this type of substances require special packaging and formulation under controlled conditions. Here are some techniques for the measurement of hygroscopicity, like the gravimetry method, the thermogravimetric analysis, the Curl-Fisher titration, and the gas chromatography. Next, here is a classification of the hygroscopic compounds, which is classified according to their percentage water uptake at 25 degrees centigrade or 80% relative humidity condition. So it is a major classification. I think that it is a noteworthy classification, and you all people can note it down because from here many questions comes. So the non-hygroscopic compounds shows 0 to 0.12 percentage of water uptake. Slightly hygroscopic compound shows 0.2 to 2% of water uptake, and moderately hygroscopic compound shows 2.0 to 15.0% water uptake, and the very hygroscopic compound shows more than 15.0% of water uptake. So I think you people should have to remember this. It's a very easy classification, and you can here see that the non-hygroscopic shows less water uptake, then slightly hygroscopic compound shows higher water uptake than that of the non-hygroscopic forms. Next, the moderately hygroscopic compound shows higher. There means the graph is increasing gradually, and the very hygroscopic compound shows more than 50% of water uptake. Now, next part is fine particle characterization. So, it is divided into two forms, like the fundamental properties and the derived properties. So, in case of fundamental properties, we can see that it is again divided into four types, like the particle size and size distribution. Next, surface area, and last two are the particle number and the particle shape. So here I can say that the particle size and the size distribution is measured by the methods like optical microscopy method, and here the important thing is the ferrite diameter and Martin diameter are also measured here. And next, the sieving methods. Next method is sieving methods. Next, and the third method is the sedimentation method. These are the parts of micromeltings, but still it comes also in the pre-formulation studies. I hope you people will also learn it further. And next is the surface area. So surface area are also measured by the absorption method, by Quantsov and air permeability method. Next come to the derived properties. The derived property contains porosity and packing arrangements, densities and volumes, and flow properties. So the porosity and packing arrangement shows open interparticular space, closed interparticular space, and interparticle space. And the densities and volumes, it contains like the true volume, true density, and granular volume and granular density, and bulk volume and bulk density. So you people will go through the equations, how to derive it, and what are the densities and volumes, how we have to derive this. It's a major part of the micromeritics. Next is the flow properties. It shows indirect methods and direct methods. In indirect methods, we can say that the first point is angle of repose. So angle of repose is the angle measured of the powder, that is a bulk of powder which contains that what is the flow of the powder, means it shows rough flow or excellent flow or what. So here equation is there like tan theta is equal to h by r. H is the height of the powder pile, and r is the radius of the powder which is on the floor. And next, bulk density, it is measured by Kerr's index or compressibility index and Hausner's ratio. So what is the formula of Kerr's index or compressibility index? The tap density minus port density by tap density. And Hausner's ratio, the tap density, the equation is tap density by the port density. So I think here are some also some uh, different types of flow, like less than equal to 10% shows excellent flow in case of Kerr's index, and in case of Hausner's ratio, the value, if the value is between 1.25 to 1.5, it shows excellent flow. And some direct methods are also there: Hopland flow method, enhanced water penetration, and recording flow method. So I say that these are the things which we have to read in the bulk characterization method, and then we will continue our next lecture with the next topic. And thank you for your patience.